Will a pole reversal occur soon? The Earth's magnetic field is known to occasionally reverse, but when can we scientists anticipate the next pole reversal to occur, and what will happen as a result? Well, if we consult a new research studio on this subject, the outlook for the magnetic field's future seems to be anything but rosy, after all. It seems that the collapse of the Earth's magnetic field 42,000 years ago not only triggered dramatic global climate and environmental changes, but also a devastating mass extinction. Are we now facing a similar scenario, or are we better prepared for such an extreme event today? Stay tuned until the end. And find out together with us. We are looking into the magnetic field future with blinkers on. After all, the European Space Agency ESA admits on its official website that currently no one can foresee how much the Earth's magnetic field will weaken in the future, and what this will mean for life on Earth. What we can say with certainty, however, is that the Earth's magnetic field is by no means static. Instead, it's a constantly changing entity that not only changes its field strength, but also shifts its poles expressed in figures. This means nothing more than that the magnetic field's north pole has been shifting further and further northwest at an annual rate of up to 65 kilometers for almost 180 years. With regard to field strength, experts have determined that this has decreased by 10% in the last 150 years alone. And mathematically, if the rate of decay remains the same, our magnetic field would have completely disappeared in 1600 years. But in reality, and this is the good news, scientists agree that this unwelcome scenario will explicitly not occur, and that we will not suffer the complete loss of our natural protective shield. After all, we must not forget that the Earth's magnetic field is just that, a natural shield that protects us from potentially destructive phenomena such as solar storms, thus preventing extreme turbulence from space from damaging or even destroying the Earth's atmosphere. As mentioned at the beginning, the Earth's magnetic field also has the property of reversing its polarity at irregular intervals, on average every 200,000 years. And as soon as this happens, the magnetic North Pole and the magnetic South Pole swap positions initially. The field gradually changes polarity over thousands of years before a magnetic South Pole becomes a magnetic North Pole again after tens of thousands of years. However, the consequences of such a magnetic pole jump for nature were uncertain for a long time. On the one hand, past analyses have uncovered no evidence that magnetic pole reversals have triggered mass extinctions. But, on the other hand, there is some evidence that protection against radiation from space is extremely weakened during a field reversal. But now we know better, thanks to a research team from the University of New South Wales in Sydney. We know that the reversal of the magnetic field actually has a potentially devastating effect. More specifically, the researchers led by Chris Turney focused on a 42-year-old 60-ton quarry tree trunk that had been pulled out of a swamp during construction work. And while the bark showed that the tree had grown for at least 1,700 years, radiocarbon dating allowed the scientists to narrow down the exact age of the tree. This is crucial because it enabled the experts to track the changes in the magnetic field strength during its lifetime, the cause of a mass extinction, to uncover the corresponding changes. The ratio of the carbon isotopes, C12 to C14, is the scientists' main emphasis, and the idea used here was that the higher the C14 number, the more cosmic radiation there is. According to the analysis that followed, the Earth's magnetic field had experienced significant fluctuations over the centuries, before dropping to about 6% of its current strength approximately 500 years ago. At that time, the pole shift finally took place, and the field gradually recovered before dropping once more, and the pole shift reverted to its initial direction. According to Chris Turner's explanations, there was essentially no magnetic field left at that time, making our blue home planet virtually defenseless against cosmic radiation. This likely had dramatic consequences. Other data from ice cores have revealed that the Sun was displaying a minimum of magnetic activity at that time, or that even more cosmic radiation reached the Earth than usual during this phase. christened as the Adams occasion. The extinction of the megapona on Tasmania and the Australian mainland also happened at the same time during this phase. But the Adams event also occurred during the time when Australia's landscape began to resemble dry steppes and deserts. Furthermore, the authors of the study state that the pole reversal could also have been linked to even more far-reaching developments, such as the extinction of the Neanderthals or the sudden appearance of figurative cave art. The latter is explained by the fact that as a result of the drastic changes in their environment, people at that time may have increasingly fled to caves. But what exactly happened back then? Well, scientists say that cosmic radiation penetrated the atmosphere, unhindered, tearing apart air particles, separating electrons and emitting light. In other words, the ionized air literally fried the ozone layer, and thus kicked off a dramatic climate change affecting the entire planet. This process was then reflected not only in the form of countless northern lights, but also paved the way for electrical storms and a rapid increase in UV levels. And, as already mentioned, this is likely to have driven our ancestors more and more into caves, which served as natural shelters. The red ochre that was often used to make handprints, there could also have been used as a sunscreen. But, as we know, the era in which humans retreated to caves was a few days ago. So how would the consequences of a magnetic pole jump affect our modern societies? Well, in this case, we would expect cosmic radiation to have a severe impact on our power and satellite networks, and thus rob us of a fundamental pillar of our present-day civilization. But the whole magnetic field truth also includes the fact that, according to other scientists' model estimates, Teeny and Company's conclusions are anything but uncontroversial. The study's authors essentially concluded that the ozone layer was harmed by the unrestricted radiation bombardment, which decreased the amount of heat absorption of UV light at high elevations. The resulting cooling at high altitudes then influence the wind systems with dramatic climate effects as a result, but it's precisely at this point that many an outside researcher becomes skeptical. After all, such drastic climate changes should actually have been evident in ice cores. This is generally the case with climatic fluctuations, but none could be detected for the period 42 or 0 years ago. It's true that individual indications of local climate change in the Pacific have been discovered in ice cores, but this does not apply to a global change for the period of the polar jump, and so it happens that its suspected consequences, such as the disappearance of the Australian megapana, are still anything but carved into scientific stone. When will the next pole shift occur? So, looking back at the history of pole reversals seems to be highly controversial, but it's not quite as hopelessly confusing as that. After all, the researchers' discussion only refers to the effects of this event. What we do know, however, is that 42,000 years ago, it was only a partial reversal of the field which lasted only 800 years. The last real pole reversal, on the other hand, occurred 780,000 years ago and lasted for 22,000 years. That we can determine the time frame of the so-called bronze Matayama reversal. So precisely is thanks to the analysis of rock and sediment samples. Furthermore, researchers have determined that such pole reversals have occurred about 70 times in the last 40 million years. But what about the future? Can we even say when the Earth's magnetic field will reverse next? Well, this question is particularly tricky because the pole jumps simply don't follow a fixed pattern. In other words, there are simply no reliable predictions or even a constant frequency at which the magnetic poles reverse. There could be thousands or even millions of years between them, and yet some current developments could at least shed a little more light on the magnetic field. Darkness, the bottom line is that the currently observed decrease in field strength is even more pronounced in some regions, such as the South Atlantic, than on the rest of the globe. So anomalies of the total field are emerging, and some researchers recognize the previously impossible pace of this development as a clear indication that part of the Earth's dynamo is already running backwards. But if we just assume at this point that the course for the next pole jump has actually already been set, will it then trigger another mass extinction? Well, that is precisely the question. but we simply cannot estimate the answer. At this point, what is certain, however, is that over millions of years nature has successfully withstood even such dramatic upheavals of the world, and in fact many species have even evolved during a pole shift, and last but not least, there is of course the study by the Swedish University of Lund took a detailed look at the last 9 years and came to the conclusion that the current changes are by no means unique, and that we may even be facing a magnetic field reversal. According to this, anomalies like the one in the South Atlantic would rather represent recurring phenomena that can be traced back to the fluctuations in field strength. And if this is really the case, then the South Atlantic anomaly could be a thing of the past again in 300 years, and the time when you missed our new videos can be a thing of the past. In just a few seconds, simply press the thumbs up and subscribe to stay up to date from now on. We'll see you soon.